Hi there. Now in the last video we have learned how recursion works internally, and we saw what's happening in the stack memory when we call a recursive method. And as you remember, in the introductory lecture of this section, we said that any problem that can be solved using recursion can be solved using iteration. So here in this video, we will compare recursion versus iteration. All recursive algorithms can be implemented iteratively, although sometimes it's much complex to do it. Let's look at these two examples which is implemented in both ways. So here, methods calculated n power of 2. As a parameter, as you can see, both method takes n, which is an integer. In the recursive function, we have an if condition, which is the base condition to stop the loop. And then if the condition is not satisfied, the function calls itself recursively. In iterative solution, we start by creating two variables over here, which is I and power. And while I is less than n, it multiplies power with 2, and in each iteration I is increased by 1. So if you look at this piece of code, we can see that recursion code is easy to write compared to iterative code. You might not notice it here in this code because it's very simple function, but there are many situations that converting a recursive function to iterative function is extremely difficult. The second point here is a conditional statement decides determination of recursion, but in iteration, a control values decides determination of iteration. In this case, the value of I decides determination in case of iteration. Here, in recursion, infinite recursion can lead to the system crash, whereas in iteration, infinite iteration consumes CPU cycles. The next point is recursion repeatedly invokes the mechanism, consequently overhead of the method cost. This can be expensive in both processor time and memory space, while in iteration case we don't have such problems. A recursive algorithm can be very space inefficient. As explained in the previous video, each recursive call adds a new layer to the stack, which means that if our algorithm resources to a depth of n, it uses at least n memory. So for this reason, it's often better to implement a recursive algorithm iteratively. So the question is, does the recursion work always better than iterative? The answer is no. Each of these codes has its advantages. We use recursion especially in the cases we know that a problem can be divided into subproblems. And when we deal with data structures like trees and graphs, the usage of recursion is more efficient. Below table describes the differences between recursion and iteration. Now the first point is space efficient. Now you see that recursion is not space efficient because in each call we have to add these methods to the stack. So if the number of calls is n, it will take n space complexity. So in the memory. So that's why it's not space efficient. Now in case of time efficiency, we have problems with recursion as well, because in this case system needs more time for pop and push elements to the stack memory, which makes recursion less time efficient. But in case of iteration, we don't have such problems, so that's why in case of time efficiency, the iteration is better than recursive. Then this third point is easy to code. So we know that to develop a method using recursion is easier than iteration, but in this case, both of them are easy, but if the problem is very complex, you will notice that writing iterative solution comes extremely difficult. So we are using recursion especially in the cases we know that a problem can be divided into similar subproblems. And this pattern is called divide and conquer pattern, and we will have a separate section for this pattern, and we will explain everything in details in that section. So with this we have completed our lecture. So here we have compared recursive solution with iterative solution. So hopefully you have understood the main differences between them.